All right, well, hello everyone, and thanks for joining the webinar Virtual Power Plant, Separating Fact from Fiction, hosted by Commodity Technology Advisory and Narrativio. Thanks also to our panelists for sharing their insights with us today. I'm Tanya Graw, co-founder of Narrativio, a niche marketing agency focused on content for energy technology companies, and energy transition technologies such as VPPs are key topics for our clients, and so it's also something that's very interesting to us. Before we dive in, just a couple of housekeeping points. First of all, a recording of the webinar will be made available to all attendees after the event. And second, if you have any questions, please submit them at any time using the Q&A feature, which you can get to by clicking More at the bottom of your screen. We will try to get to as many questions as possible at the end of the webinar. So around the world, from the US to Europe and Australia, the virtual power plant industry has been experiencing massive annual growth for several years already. Aggregating distributed energy resources like solar, battery, and flexible loads through VPPs has been promoted as a significant tool to add flexibility to the power grid as we move toward net zero. But is this a realistic view, or are VPPs overhyped? What opportunities are there really, and what barriers stand in the way? With our expert panel, we will answer these questions and explore the technical, commercial, and regulatory readiness of VPPs, shedding light on the complex and sometimes misunderstood world of this topic. I'll now turn things over to you, Irina.
Thank you, Tanya. So my name is Irina Graw, and I am working in energy industry more than 25 years. And currently, I am representing here ComTech Advisory, which is a leading market analyst organization for software vendor market in energy. My focus within the ComTech Advisory is energy transition technology, where VPP is a very important part of. So in this webinar, we will raise a lot of questions to our panel, but before starting with the questions, I would like our panelists to introduce themselves. So please start with Christoph.
Yeah, thank you. I'm Christoph Malzer, as you can see here. I'm in the energy industry or software for the energy industry now for 15 years, having done some implementation work of ETRMs and many other things. Joined Navitasoft, what you can see here, half a year ago, helping Navitasoft growing the business in the VPP field, in the ETRM field, and TSO field. Thank you.
Thank you. Brock?
Yeah, hi everyone. Thanks for having me today. My name is Brock Mosovsky. I'm the co-founder and VP of Analytics with cQuant.io. cQuant is a software as a service, energy analytics focused organization. So we provide analytical tools for the energy industry, for independent power producers, for renewable developers, for trading organizations and consultancies. I've been working in the energy industry for about 12 years now. Most of that time spent doing portfolio analytics and risk management across a variety of different portfolios. So really excited to be talking about VPPs with you all today.
Thank you. Edvardas?
Hello, everyone. My name is Edvardas. So I'm representing Fusebox. We are offering software as a service as a VPP for the utilities mainly. And I'm working in the energy field for 15 years already. And with the flexibility VPP questions, more than 1.5 years already.
Thank you. Dan Quart, please.
Yes, I'm called Kaldemeyer. I work for A&E Energy. We are a trading company from northern Germany and mostly trade renewable energy on different short-term markets. And in my position, I work as a project manager for research and development. So I'm familiar with the virtual power plant and all different things, flexibilization and that sort of thing. Thank you.
Thank you. And finally, Marion.
Hi, good afternoon, everyone. So I'm Marion Malafosse. I'm head of policy of smartEn, which is the European Business Association for Demand-Side Flexibility. We gather around 100 members now that are part of what we call the flexible demand management industry. So we have provider of smart technologies, smart services for all of the end-use sectors, building, industries, and also electric vehicles. We also gather aggregators or market operators that set market platform for the trading of flexibility.
Thank you. Thank everybody for this introduction. And so let's start our webinar. And here we're talking about VPP, but what is actually VPP? I mean, usually under VPP, people understand the concept which involves connecting different decentralized energy resources into one network, which can be centrally controlled. And there are different types of VPP. People talk about production-oriented VPP, where mainly renewables, but not necessarily only renewables. There are consumption-oriented VPPs based on demand response, and most complex VPPs with mixed assets. And of course, batteries can be a very important part of the VPP as they bring the flexibility into the VPP, which is really very important here. But the most maybe special feature of VPP is being centrally controlled. Why it's so important? Because it makes it possible for VPP to be traded on the market. And that brings us to the whole value chain of the VPP. So first you need to aggregate your distributed assets. You need to forecast consumption or production. You need to deliver this information to some trading entity who will then realize flexibility of VPP on the market, where some analytical tools optimization is necessary to understand how to use that flexibility and on which market. And then resulting schedule needs to be communicated to the TSOR, DSOR. Finally, the distributed resources must be dispatched and settled. So you see a lot of steps where some technology is needed to support the VPP. And here we want to understand how mature is that technology. So in the beginning, we will start with technical maturity to understand, do we really have all technology needed to support VPP, or there are some gaps? Then we come to the commercial side of things and to see if VPPs are currently commercially viable. And at the end, we will look at the legal framework, because if you participate on the market, then market regulation is needed to support that participation. And so, starting with the technical side of things, I would like to ask the panel my first question. How do you see the technical maturity of VPP technologies now? And if they are mature, what are the challenges on the way of adopting this technology in reality? So with this question, I will start with Christoph, please.
Yeah, thank you. Yeah, well, I mean, VPPs are nothing new, and those ones out there, they are mature, I would say. But the VPPs out there right now, they are typically one asset class. So let's imagine some pumped hydro. And these ones operate then in one or two markets. So for example, intraday or an MFRR market. And if you only have more or less a single class asset marketed in one or two markets, the settlement is rather easy. So share the revenue, what you gained, and fulfillment, what has been done by the asset, by each individual asset compared to what it was supposed to. And also the optimization, especially for pumped hybrids, it's not so simple, but that's something that is out there now for many years. But when we come to the new VPPs, so with a flood of renewable assets coming in and with a flood of let's rather say flexibilities out there, totally new challenges come along because the assets are smaller typically. So connection costs are a key driver, how small you can go with the assets you're about to connect. And standardization of the interfaces, that's something what we will learn a little later about. And well, having thousands of assets out there Then the optimization, that's next level optimization, which asset should run in case of an activation by the TSO. How is the settlement being done? How would you like to share the revenues you gained? And well, the fulfillment. So has this little heat exchanger done what it was supposed to? If it's just a 1, 2, 5, 10 kilowatt asset, then connection costs again come into place here.
Thank you. Edvardas, you are working on the VPP technical side of things. What do you see here?
Yeah, so about the technical part, that we are operating the VPP, and the VPP consists from totally different assets. It's like consumption side, I mean cold storage, HVACs, different system. And in the same portfolio, we have battery storage, the same hydropower plant. So I would say that different technologies on the learning curve as well, because we are operating, we are trading, but to gather different assets in one single portfolio and to be precise, it's a challenge, but we are solving this challenge, and I'm really happy to do so. And with a smaller asset, what I see in the technology, that the installers have their own platforms where we can connect. So it means that as VPP, I don't need to go down to the household. Sometimes some other installer or platform bringing it to us huge amount of assets, like thousands of installation, what they are doing, their usual business, but they have their own platform to integrate them.
Mm-hmm. Thank you. Someone else wants to add something here? If not, then we will go to the next part and now discuss commercial side of things. Yeah? VPP is divided through the central control and possibility to realize the flexibility on the market. But what is the mechanism of this market participation? Which markets are available for VPP? And how that's typically done now, and what is expected or hope to be in the future? So let's start with Core. This time, please.
Yes, thank you. Yeah, we use our VPP to control and monitor our physical and mostly decentralized assets. And of course, the markets depend on the scope of the VPP and the respective assets and business models. So potentially we can go to electricity markets like short-term, day ahead, intraday. We could also potentially use it on OTC markets. Then, of course, use or ancillary service markets like FCR and AFRR and MFRR. And we as a trading company use the VPP for the renewables like wind, solar, and biomass, for the direct marketing, mostly in wholesale markets like day ahead and intraday, and OTC. For the battery storage, we also go into the wholesales, and now at the moment we are entering ancillary service markets, like starting that as a project. And of course, on the other side, if we have flexible consumers, such as power to heat or power to a vehicle to grid, for example, we also go into wholesales, but they are also evolving, and potentially we could go into ancillary service markets as well if we have the right platform behind it.
Mm-hmm. Thank you very much. Christoph, do you want to add something?
Yeah, well, I think that the most important thing to mention here is that the asset must fit to the market. So if you have an asset which can run whenever you want it to run, but because it's fueled by fuel, for example, then of course wholesale market is an option. If it's an asset which must be charged as a battery, for example, that's rather something for ancillary services, probably AFRR, or this is speaking about the continental European market. In Britain, that would be different. That could be dynamic containment or balancing mechanism, for example. to make a long story short, the asset class must fit to the market.
And you think that the battery would be mostly used in the ancillary service market, but what about short-term or continuous market when you help, for example, to reduce the peak price by providing power from the battery?
Well, again, it depends then on the asset or the battery itself, the battery size, if it can participate in the intraday market and for how long it can participate in the intraday market.
Thank you. Someone else want to add something?
I would like to elaborate on the different markets. So you need to understand that VPP is a capability to enable flexibility, and then traders comes in and decides which day, which hour the best profit comes in, and it one day could be intraday trading, next day it could be ancillary services like AFRR, MFRR, FCR. You know, even though if we are talking about the battery storage, like different countries have different support scheme, capacity markets, and different trading possibilities. So different market, different opportunities there.
Kurt? You wanted to add something?
And I wanted to add that the markets are and the prices are constantly changing. So what you do in practice, or what you would do, is to make multi-market optimization and see which one, in which times provides the most for your asset. So
yeah. Thank you.
it's important.
Yeah, one more here. Well, the British battery market, I think, showed a lot in the last year. So after ancillary services was saturated by batteries, the dynamic containment price plummeted. So that's one of the key pictures to keep in mind. If it's, well, I mean, that's common sense, but apparently it was not there. Once the market is saturated, never expect that the prices continue as they are now.
Yeah, no, sure. That's we've talked about current status of the market, of course.
Yeah.
I'll just add to kind of underscore something that Edvardas mentioned, which is that the VPP is really providing kind of flexibility. And so there's a lot of parallels between a VPP of various different types and energy storage that we're seeing on the grid. And so I think there's some synergy in terms of the market actually realizing, or participants in the market realizing, how value can be derived from these assets. And there's a lot of cross-pollination from lithium-ion batteries and other types of energy storage that are now participating in the market and have gained much broader adoption. You know, as some of the panelists have mentioned, VPPs have been around for quite a while, but I think there's been a struggle to determine exactly which markets they should participate in to derive the most value. And the involvement of battery storage and the adoption of that technology and the range of different trading strategies and optimization strategies, I think, is kind of feeding into VPPs as well. So there's some really nice synergy there in terms of how the flexibility can be monetized from a VPP that is leveraging some of the lessons learned from more traditional kind of direct energy storage.
Thank you. And then, Marion, please.
Yes, maybe what I would like to add, and I think it was also touched by the other panelists, is this idea of value stacking. Because if we want VPP really to generate sufficient revenues, indeed, this optimization of which market it is best to operate on is really important. And we see that there are some restrictions or technical requirements that would only limit VPP to act on a specific market and not allow it or enable them to then also generate revenues on other markets. And this idea of value stacking is extremely important then to be able to generate sufficient revenues to then boost also the commercial viability of VPPs.
Thank you. And with that, we can go to the next questions and discuss different type of VPP, more demand-oriented VPP. Actually, demand response can be seen as two types, so to say. One is industrial demand response and residential demand response. And when we are talking about the consumption-based VPP, we mean mainly the provision of the demand flexibility for the market via VPP. Now, industrial demand response usually express itself is kind of peak shaving products, and again, not something very new. But on the residential side, there are a lot of questions. So people are very eager to install solar panels on their houses and so to contribute to the energy transition and supply themselves with some energy. But when it comes to the giving control over their devices to some VPP, to some third party, usually people are quite reluctant. And here I have maybe two main questions. One is it really important that residential demand response is included into the VPP, into the energy system? Does it play such a big role? That's one thing. And the second question is, if it is so, how people can be motivated to take part in the VPP and to give control to the third party? Yeah. And here I will start with you, Marion, please.
Sure, absolutely. These are two very important questions. So first of all, maybe let me take a step back. What is important to know about the context is that the flexibility needs of the system are on the rise. So at EU level, they will increase for daily flexibility needs. They will more than double by 2030 and more than quadruple by 2050. So that means that we really need to harness the flexibility potential of all end-use sectors. And it's true that most of the flexibility that is being harnessed today comes from commercial or industrial consumers, but an important potential also lies at residential level. So this residential flexibility is extremely important. And we already have some electrified assets at residential level that are called non-dedicated assets because they are not providing flexibility, but they could really provide important potential if they're connected to the system as a flexibility resources. And VPP at residential level would be aggregating electric heaters, heat pumps, boilers, batteries, but also EVs that are installed at the residential level. So in short, the answer is yes, residential flexibility within the VPP is extremely important. But now the question is, what do we need? How do we motivate consumers? An important starting point is that we need to create incentives for consumers to actively adapt their consumption where it's needed and when it's needed, so that it operates dynamically. And these incentives are twofold. First, they need to receive the appropriate signals in terms of prices. So smart meters rollout or dedicated measurement devices are extremely important in that regard. And then we also need to, as an incentive, to ensure that the consumers get the revenues of their activated flexibility. This is extremely important. And so for that, we need to address barriers for the valorization of flexibility resources onto electricity market that is coming from the residential level. This is the only way that this can be valorized and generate revenues that could then trigger down to the individual consumers in terms of revenues directly from the electricity market, but also reduced electricity bills. And this way, this will create the financial incentives that are necessary then for consumers. And I think it would be a very important driver then to motivate them to be able also to accept automation of their devices or to give some control of their devices, provided, of course, that preferences in terms of comfort are safeguarded. And this is actually the case with aggregators. They also respect the consumer's preferences in terms of comfort, in terms of usage of different devices. This is also part of the contractual agreements. But this financial incentive is extremely important to kickstart and motivate consumers in this endeavor.
And thank you very much. How do you see that, Brock?
Yeah, I think I would agree with basically everything that Marion said. If we kind of segment the industry into industrial and commercial customers and residential customers, we know from experience that not only are the industrial and commercial customers kind of bigger individual resources, so you can go to one particular participant and receive more in the way of energy or frequency regulation response, those different products, right? So you're getting more from a single entity. So there's less aggregation that we need to do, which simplifies the problem. But also we know that because those entities are businesses, they tend to be more rational, a little bit more profit-oriented and economics-oriented than a consumer who may place a very high premium on those comfort aspects, right? I think that the residential component is a critical one as we kind of move into the energy transition more deeply. I think adding things like rooftop solar, like electric vehicle charging, even electrification of heating systems, which is a trend toward heat pumps and more electrification overall and reduction in fossil fuels. I think all these things are going to increase consumption. And so a big chunk of that will be coming from residential customers, each of whose loads are a little bit smaller independently, but together that comprise a big chunk of the evolving electricity demand. And so, to get into what can we do to properly incentivize those customers, I think that and again, I think Marion hit on this very nicely, but there's a psychological component we need to acknowledge, and there's an economic component we need to acknowledge, and we need to be able to do both of those simultaneously. And traditionally, that's been, I think, a big challenge. We've talked about within the industry, we've talked about coordinated water heating, smart thermostats, various different VPP technologies now for decades, really. And the challenge has always been, there's of course a technological challenge, but I think there are solutions out there, but a big challenge has been the behavior modification. And when you look at particularly residential customer behavior modification, I think that there's a very high threshold in terms of the economics that's required to allow the customer to relinquish that control, because there's kind of a lack of trust and there's a skepticism about how it's going to impact them. I can offer one anecdote. I participated in an early stage kind of demand response pilot program with my utility, which was reduction in cooling load. And I participated for an entire summer. And I had an interview with the utility at the end of that program. And I said, well, how much would you estimate that I saved on my bill? And being involved in the energy industry, I was very conscious of my behavior, and I really made the effort. And they said that the overall net savings was less than $10. So for an entire season of participation, from my perspective, the economics just was completely immaterial, and it did create a significant discomfort. So I think there's still some challenges there that we have to overcome. We need it to be automated. We need it to be, we need to minimize the inconvenience to the user, and we need to be able to see an economic benefit.
Thank you. I mean, I think just a thought, the way to maybe convince consumers, at least this overcome the psychological component, is to say that, for example, if your device is switched off centrally due to something and that brings you extreme discomfort, you can overrule it manually. And so when people know that they can always overrule, maybe they will less reluctant to accept that. But I agree. So this financial component is a big problem because the savings are not that great usually. If someone else wants to add something on this topic, Christoph, let's do a few first.
Well, Brock, you mentioned it must be automatic or automated. That's a key topic, I think, key issue. But it also must be as simple as signing up for a Netflix account or buying something at Amazon. And typically, whatever comes from the utility comes with a bunch of these here. And nobody wants to do so to save $10 a month.
Yeah.
That must be simple and stupid.
No, of course. Edvardas?
Yeah, I would elaborate that the role of the households in the VPPs right now, it's quite low, but it's coming, and will become like significant role in the VPPs. And right now I'm looking at the industrial side, that like low-hanging fruits, to collect, aggregate them. But with the heat pumps, boilers, we will have a huge amount, even though I met several technologies who are working with the thermostats, with the air-to-air heating or cooling. So like the market
Power
is coming and
charging is
growing.
usually very considered to be very important in that, because it's a lot of energy which is consumed by power. I mean, by the way, there is a study for Germany saying that total flexibility of the residential side, so demand response flexibility, can be accounted to 10% of total German consumption. So it's not huge, but it's essential. It's nothing. It's not nothing. It's something really to look at. And this is looking into the future. It's not current status of this. So, okay. If nobody else want to add something here, please, Marion.
Yes, just a very small, short remark, but on the financial benefits that consumer can get, I think we should also be clear that now more and more we see quite significant financial benefits as well. Because yes, this example of the $10, but we see, so that clearly is not significant enough. But with our members, and we've done this, I'm hoping that now with the background you can see that, is a communication on why flexible consumers matter. And here we've highlighted already existing use cases where at residential level, if they activate the flexibility, they can save on their electric bill. They can reduce it by 25% for their electric consumption for heating, thanks to demand-side flexibility. Or if we compare also the cost of a heat pump compared to, so we look at, if you have a gas boiler, you switch it to an electric heat pump, and then this heat pump becomes flexible, you could reduce the cost of running this heating by 300 euros a year. So that's already quite significant reward, and that have an impact on your monthly bill that you could actually feel in your pocket.
Yeah. It's much more compelling.
Yeah, it's interesting. Yeah, I didn't think that it's that much.
Yeah, and it's already happening now, and it can be even more if we have all of the barriers to demand-side flexibility that are lifted.
Thank you very much. Somebody else, or we should go to the next question then? And now let's talk about battery storage and the financial profitability of the battery storage. So battery storage is a very important part of the VPP as it provides the flexibility which market needs, and where we think that such a battery storage would be probably very important part of the VPP, no matter if it is on the demand side or production side, especially if battery storage is co-located with, for example, renewable plants. And maybe the first question would be, if we look at the batteries standalone and look at the current level of market prices, what be the profitability of such a battery? So there are certain investment costs which are not small, especially with the big battery installation. So what do you think about profitability of the batteries and such? And maybe I will just ask the second question, then you can answer both of them at the same time. Are there any estimates from the utility perspective? If you add a VPP to utility, how much profitability additionally you will get out of that? And let's start with you, Brock, now.
Yeah, batteries, excuse me, batteries are such a kind of a trendy component of the energy industry, but for very good reason, I think. And we talked a little bit earlier about the VPP's ability to revenue stack, right? To access different revenue streams at different times as market conditions change. And I think not only are batteries, so batteries can do the same thing, whether you're operating in a wholesale context or a behind-the-meter retail context. And that flexibility of the asset's operation and the flexibility to access those different revenue streams, I think, is a really important component of what batteries bring to the table, because we know that the markets are evolving and pretty rapidly in some cases. One of the panelists mentioned that one of the reserve markets or frequency regulation, the prices just tanked when that market became saturated with storage. And we're seeing similar dynamics in the United States as well. And so while a lot of batteries are deriving their value in one way today, we expect that will change over time. And the benefit of the battery is they can participate in those different markets. So that flexibility component, it's a very hard thing to quantify. But I think one of the ways to do it is to look at kind of the optimal operation of the battery under different scenarios, and to have an analytical framework or a valuation framework where you're looking out ahead, because these are 15, 20-year assets in many cases. So you've got very long time frames where you need to have the asset perform, and within that time frame, there's just so much uncertainty in terms of what the markets are going to look like. So you can base your initial analysis today off of what you know, but you want to be able to stress that and push that around to determine value for the battery. I would say that that's probably the best way that a utility can also approach the valuation of a VPP, is that in the same way there are a lot of parallels between a virtual power plant and a battery, and being able to run scenarios on different market components, different operational strategies, different value streams, and understand where the sensitivity may lie in the value proposition, I think is extremely important to value an asset today on the grid, but also to kind of value it long-term and gain enough confidence to make an investment decision, because these are big capital investments, right? So that's, I guess, what I'll start by saying there.
And who else would add something here?
Yeah, I can agree on this. If we, for instance, look at the development of the energy prices in Germany and the revenues of the battery storage, you see, for instance, in 2021, you had moderate wholesale prices, and then you had like boosting FCR prices that led to very high profits. Then in the next year, you had like coming and rising intraday prices and record profits due to the crisis we had here, you all know. And now this year or last year, the intraday and FCR prices stabilized again, but now FCR prices are increasing or have been increasing since last summer. So you have to be flexible, like to as Brock said, you have to look at the markets. You need a framework to see the value, and then you can add the different revenues to make an overall profitability of your asset.
Okay, thank you. Any more answers to this? More comments? If not, we will come to the third part of our discussion and talk about legal component. So if you look especially on Europe, you see quite fragmented regulations concerning participation of VPP in different markets. And of course, there are different types of VPP. If, for example, VPP is a part of a utility, and just to add some more flexibility to assets which utility anyway has, it's clear that through utility you can participate in every market. But there are also other market participants. There are those aggregators. There are some project developers which build batteries standalone or batteries together with some renewable power plants. So how participation in the market look like for these new entities currently, and how the regulation is going to evolve? So what do we see from this across Europe at the beginning, and then maybe example of the US as well. So let's start with Europe, and Marion, please, that's your question.
Yes, absolutely. I'm happy to give a picture of what's happening in Europe. So you mentioned that it is fragmented in Europe, and that is the case. But the reason is not because we don't have the proper rules. The rules have been set at EU level. So the European Union actually put forward quite a very strong and positive regulatory framework for demand-side flexibility that is also supported for virtual power plants. We have the right for active customers that is being recognized. They can engage in flexibility services. Aggregation and independent aggregators are also recognized. The procurement of flexibility by system operators is also encouraged by European legislation, as well as the access to all electricity market by demand-side flexibility. The issue now is about implementation. So how these rules trickle down to member states level. And this is where we have this fragmentation, because implementation is not in place. And I'm talking about rules that have been from 2019. So they're not, today's or extremely recent, but there is a lag in this implementation. So that means that today we still have consumers that can't be fully empowered. They are not allowed to opt for innovative businesses or offers, or to activate the flexibility. So that is an issue. And this issue is actually becoming more and more pressing, because now with electrification, decentralization of renewable energy sources, we are facing now more and more issues on the grid, especially for grid congestion. These grid congestion aspects are on the rise in the EU. A very notable case is in the Netherlands, where they've recently seen a map of the grid capacity in the Netherlands, and basically the whole country is all red because everything is congested. So really this is a very pressing issue, but that is not isolated to the Netherlands only. So first recommendation is really to implement the right regulatory framework that has been adopted at EU level. That would be extremely important. Beyond these regulatory barriers, what's also important, and that also links back to previous discussion on the first question, is this question of interoperability and compatibility among the different decentralized energy resources that are part of the VPPs. And this differentiation and the lack of interoperability also complicates the integration efforts, and it limits the scalability of the VPP. So what's important is to ensure interoperability across also the value chain, because demand-side flexibility is extremely data-driven. But what we see is that we have different standards, different communication protocols, different between the assets, but also between the different system operators that are within the EU. So that also limits the business offers for demand-side flexibility and for setting up these virtual power plants. And then one last recommendation that I would put forward is that we need to recognize the added value of the flexible demand management industry. So as I mentioned, these are the providers of smart technologies and services, the aggregators, but also the market platforms. It needs to be recognized as a strategic clean tech sector so that it received the necessary support. And for that, we need to encourage end-use sectors to adopt these flexible demand solutions. And we need also to ensure that we have a single market for flexible assets and flexible services, so that we reduces the risk and the barriers for these offers, and we allow them these businesses to flourish. This is extremely important, and this is what we are trying to push in the European Union, so that we have a more scalable market for demand-side flexibility, and then ultimately for VPPs.
Thank you. As far as I understood now, that there is great rules and recommendations, but not every country is following to that. And maybe you can say, in looking on the European continent now, where you would say you see most advanced market regulations for VPP point of view?
So it really depends also if you look at which markets are open as well. But we see, for instance, regarding the aggregator models, you have a lot of advancements, for instance, in France. In the UK, you also have a lot of possibility to valorize flexibility. But then you have also some limitation that you can see in other markets where you don't have enough price signals or enough dynamic price electricity contracts that also reduces the signals to consumers. And that, for instance, could be in Germany with the lack of smart meters rollout. That is also an important issue. So depending on where you look at, you have different development and progress throughout the EU as well.
Yeah. Rob, do you want to tell us what's going on in the US from that point of view?
Sure, yeah. There's a lot of parallels, I think. I think the idea that there's some centralized guidance from a regulatory standpoint. One of the important regulatory frameworks that came out in September of 2020 was FERC Order 2222, which required grid operators to support virtual power plants as bidding into the markets as wholesale resources, right? So that aggregation, it was kind of a formal ruling that required the grid operators to accept those bids, aggregated bids, as if they were wholesale resources. And so I think that laid some groundwork. But again, we have 7 different independent system operator, regional transmission organization markets. And so each one of those the markets are slightly different. The way that those VPPs can interact with those markets is slightly different. So there's still a bit of fragmentation there in terms of how they're participating in the markets. I think that regulation is kind of forward-looking in the sense that we're acknowledging that these are going to be important things in the future. And I think Marion mentioned this as well, but as the grid continues to evolve, the value of flexibility on the grid and the value of grid management is going to rise pretty substantially. And if you look at kind of current frameworks by which energy generators have been traditionally compensated, you typically, not in all markets, but in the US, in most markets, you have capacity payments and then you have energy payments. And those are by and large the 2 main sources of revenue. Well, when you look at kind of the energy payments, those are the price for energy at any given time is related to the marginal cost of generation at that time. And when you go to a grid that's 100% renewable or very close to 100% renewable, the marginal cost of that generation is 0. So the concept of locational marginal price kind of indicates that price is going to go to 0, which would mean that the energy revenue from the generation component is actually declining. And so that value has to go somewhere. And I think it needs to go into grid management, because the big challenge is going to be, how do we manage the energy that is coming onto the grid in terms of shifting it from the time when it was generated to the time when it was needed, in terms of transporting it to locations on the grid that require that energy, in terms of keeping the grid stable. All of these different components are areas where VPPs and batteries and different flexible resources can contribute. And so I think that we've kind of laid a foundation for participation in the markets, and we've laid a regulatory framework that we can build upon, but we're still in the very early stages. And this is something that is going to evolve, which doesn't give a ton of certainty to asset owners and asset operators and VPP operators, because we know that this is going to change. But I think when you look at the landscape of the energy transition, it's going to have to play a very critical role. And it's good to know that the centralized governing bodies are kind of aware of that, and they're thinking in a forward manner to kind of support that adoption.
Thank you. I think you touched a very important topic, that the flexibility needs to be on the batteries, on the grid, and grid development is definitely one of the key points, and that's already realized by authorities, I think. So anyone else to that, please?
I would like to elaborate a bit with the Fusebox. We were growing, and the same experience to share the legislation restriction we had, like ESO, and when it comes to utility, so they are reacting okay. There's the planning, you're making the delivery, and when aggregators come, like, no, you have different rules. So it means that it's difficult to compete with the same the same megawatts, but your aggregator and your utility, then you have different rules. And when you're starting to ask why is it so, because the same energy, the same megawatts, and then they understand that it's need a change, but it's really slow. So for TSOs, it's a learning curve as well.
Thank you. Anyone else? If not, I want to thank everybody for very nice conversation, and we have still few minutes left, and we got the questions. So I give the word to Tanya, who will lead us through the questions which were asked during this panel.
Thanks, Irina. Yeah, we have a lot of questions. So I'd like to get to as much of this as possible. So I'd also like to ask, and there are some very, very good questions here. So I'd like to ask that we keep the answers short in the interest of time. But the first question is, the benefits of the growing share of VPP dispatched power are clear, but are there any downsides or risks on a grid level that need to be addressed?
Would like to take this? I think it's something very similar what Brock was talking about before, and that definitely has a risk on the grid level, and there is a need to develop and then finance the grid in order to come to the energy system with high share of the renewable energy. Any comments?
Oh.
Well, I think it is the VPP in general is highly regulated. So from a TSO point of view to being able to deliver some ancillary services, it is clear what you need to do. I think there's a way higher risk in in some solar installations which are not regulated. So this balcony solar, that kind of stuff. I think that's some risk as well, which is not regulated at all.
Yeah, and I'll just add that, when you are without the VPP, when you look at distributed solar resources and you look at all the different generation resources, those same resources are on the grid today, and they will be on the grid without the aggregation component that really constitutes the VPP. And so what is the VPP doing to change the way that energy flows on the grid? Well, it's in a way, it's kind of coordinating it. It's not centralizing it, but it's coordinating it in terms of time and dispatch and the nature of how it flows onto the grid. And so I think that does, in some cases, it could present some challenges to the grid, because whereas the resources themselves would be distributed in both space and time, there'd be kind of a natural averaging effect across the resources. When you then coordinate those, you are structuring power flow on the grid in a way that is very two-way, right? It's bidirectional, which is very different from kind of the traditional centralized generation, hub and spoke type of dynamic that most grids were kind of developed to support. And so I think there needs to be an acknowledgement of, I'm by no means an electrical engineer, but it is, I think, potentially changing the way that power flows on the grid by coordinating these resources to all kind of fire at the same time. And that can put pressure on distribution networks and kind of change the way that power is delivered. So just something to be aware of as it grows in adoption.
Yeah.
Very shortly to close the discussion, I would like to touch a totally different point of view, that the grid is critical infrastructure. So it means that, let's say, not the downside, but I would like to raise the question of cybersecurity. Because when you have a huge utility like production unit, so it's one case. When you have distributed energy resources like VPPs gathering a lot of data and communicating with TSO, its cybersecurity question rises quite high.
Very important. Marion?
Yes, very, very last word from me, but I think we should also see the question the other way around. What are the risks for the grids if we don't have the VPP? And what Brock was also mentioning is that these decentralized energy resources or electrified assets, they're already here. So they also put some pressure onto the grid. So what the VPP ultimately does is optimize all of that in a way that provides services to the grid. So of course, if you want to alleviate congestion, you can think of grid expansion, which will be necessary, but it's also extremely costly and it takes time. So actually, I would say that VPP are part of the short-term and immediate solution that we can have at hand to try to alleviate also this congestion issue that we now see on electricity grids, and especially at distribution level as well.
Thank you. Next question.
Yeah, very, very timely question about the role of AI in VPP technology, and also some of the concerns with AI algorithms making their way into energy trading. Can we still, for instance, analyze why a deal was not done? How is risk management being dealt with?
Yeah, I mean, this is a question where one can talk a lot.
Yeah.
So I would like to ask everybody to give very, very short questions. So from what I know, AI is already used almost everywhere in the forecasting, using a lot of data, weather data, satellite data, and so on. So this is already a reality. But in trading, even in financial trading, there are some very useful AI applications for creating market scenario for valuing assets. But let's then try to get as many responses as possible and short ones. So who wants? Rob?
I can maybe kick us off. We work with a lot of customers for risk management purposes with our software. And so, the idea, I would underscore what Irina said, that AI has been in energy trading for quite a while, algorithmic trading, real-time trading, automated bid submittal. Those types of things have been in the wholesale side for quite a while. And so I think that we will see them kind of trickle into the VPP side and the distributed side. But from a risk management perspective, you need to just understand how your algorithms are going to react. And you need to put guardrails around them, right? Because if you allow that AI kind of carte blanche to transact whatever it thinks is the right thing, and you don't set those guardrails properly, you can very quickly get into a situation where you are overcommitted, or you are exceeding your VAR threshold or your GMAR threshold, or different kind of risk policies. So I think keeping things in check and putting those guardrails in place strategically is an absolutely essential component.
Someone else?
Well, let's AI do the boring legwork. So controlling 1 million assets, that's a brilliant case for AI. In addition to that, that's already out there now.
I mean, there are some applications of AI, for example, when you analyze the reasons for your revenues or profits to go up or down, you can figure out if you got wrong data or something on the market really impact your revenues and so on. So there are a lot of things where you can apply AI, but we need to know that the trading decision is always with a trader. AI can suggest something, propose something, but the personal responsibility for the trading decision is always with humans. So next question, maybe, or probably we don't have time anymore, just 1 minute left. Maybe you just give some final remarks and we would need to close.
Right, and I think there were so many other questions. Perhaps if the panelists are willing, we can do some offline answering. I can send the questions out and we can send some responses out along with the recording. So somebody did ask, and I've said this before, as I said at the beginning, there will be a recording sent out after the webinar. And but at any rate, as we've seen here, the VPP market is definitely maturing. There's a lot of opportunities, especially in, because VPPs have been around for a while, but it's really going into multiple asset classes, combining and optimizing them intelligently. bringing households into the mix and also pursuing multi-market strategies. There are a lot of opportunities. There are still a lot of barriers to overcome, and that's from all sides, technical, commercial, regulatory, but also in terms of consumer participation and the psychological barriers. That's actually maybe one of the biggest problems for the next stage of VPP evolution. And the conditions vary widely from one country to another. Hopefully the regulations will come up to speed around the world to make this more possible in all markets. Thanks to all the panelists. Yeah.
Yeah,
Go
from my
ahead.
side as well.
Thank you, everyone.
Thank you.
And thanks
having us.
thanks to the audience, and we appreciate your time.
Thank you.
Thank you.
Thank you.
Everybody, good day.
Bye-bye.
Bye.
Thank you.
Take care.
Bye.
Bye bye.
Bye.